I'm Peter Brinkman, an engineer on the speech infrastructure team in New York, and today I'd like to tell you about my 20% project, the Patchfield audio architecture for Android. In a nutshell, the idea is to allow you to implement audio functionality such as synthesizers and effects with minimum fuss, and to patch them together in a patch field as you would in a recording studio. The core of Patchfield is a service that manages the signal processing graph, and it also acts as a central hub for audio. So the service manages all your audio units such as synthesizers or effects, and it provides all kinds of functionality for connecting them. Now you can run the service locally in your app or remotely. When it's running locally, then essentially it gives you a powerful way of organizing audio within your app, and it gives you also a couple of other nice features such as support for multiprocessors. When it's running remotely, you get an added feature, namely you get support for inter-app audio routing, meaning that, say, you might have one app that just acts as a synthesizer, you may have another app that acts as an effects rack, you can connect them, and then audio signals will flow from one app to another, and you get a lot of flexibility that way. Now, in terms of APIs, there are two APIs for you to work with. There's a client API in Java, and the purpose of that Java API is to let you query and manipulate the signal processing graph. So you can get a list of the audio modules that are currently available, you can connect audio modules, you can disconnect them, you can enable or disable them, and you can do a number of other things as well. And the second API is the audio module API itself. That one works with Java as well as C, and that's what you use for implementing new audio functionalities such as, well, synthesizers and effects. All right, let's bring up a little control app for Patchfield. So right now you see we have an on-off button for enabling or disabling audio processing. And right off the bat, we get two audio modules. We get one for the microphones of the device. So we see one audio module that has two outputs, one for each of the built-in microphones. And we see another audio module with two inputs. And those are the inputs for the left speaker and for the right speaker. And for example, I might say connect one of the microphones to one of the speakers. And if I were to turn audio processing on right now, we would get horrible feedback. So let's not do that. Instead, let's launch another app. So this one is a very simple app that just loads a WAV file and gets ready to play it. And when we go back to our control app, we see that a new audio module has appeared. And so now we have an audio module for our WAV file. And let's bring up yet another little app. So here, this app provides a low-pass filter. And once again, if I go back to the control app, there's a new module right here that represents our low-pass filter. And now we can connect them. Say I send the audio from the WAV file into the low-pass filter, and I send the output of the low-pass filter to the speakers. And now, if I turn on audio processing, we hear the WAV file. Okay. Now we can go to our low-pass filter, and if we play with the cutoff frequency, you can tell that the higher frequencies go away, so the low-pass filter acts as expected. Okay, so that was the core functionality of Patchfield in a nutshell. All right, let's take a look at the code. The Patchfield service implements an interface called iPatchfield service. And this interface consists of three types of methods. You have methods for manipulating the state of the Patchfield service. You have methods for querying the state of the service. And you have methods for internal use. So when you're manipulating the state of the service, you can, for instance, you can turn on or off audio processing. That's what the on-off button in the control app was for that we saw a minute ago. You can activate and deactivate modules. You can connect ports of modules, or you can disconnect ports. So essentially, you can make the changes that you would expect. And then you have matching methods that tell you, for instance, whether two ports are connected. You can get a list of the audio modules that are currently installed, and you have a number of other methods as well. So now, if you're implementing a Patchfield client, and you would like to keep up to date on changes in the state of the Patchfield service, then you can implement this iPatchfield client interface. And now, if you register yourself with the Patchfield service, you will get callbacks whenever something happens. So you might get a callback when a module is created, or when a module is deleted, when ports are connected or disconnected, and so on. So this was essentially bookkeeping. The interesting part really is the audio module API, because that's where you implement audio functionality. So the foundation of it is a class called audio module. And it's an abstract class that has 4 methods that you will need to implement. The most important of those methods is one called configure. Where is it? Here. And the purpose of the configure method is to connect your audio module object to the corresponding data structures in the Patchfield service. And let's see how this works in practice. So let's look at the low-pass module that we saw in action in our little demo. So here's a module called low-pass module, and it extends the audio module class that we just saw. And sure enough, it implements the configure method that I just mentioned. So now this configure method internally just takes the handle that it received before and the number of channels that it wants, and sends it to a native method called configure native components. So let's look at the implementation of that native method. That's in a file called lowpass.c. It's right here. And this method allocates space for a data structure that will hold all the information that characterizes our low-pass filters, such as update coefficients and filter values. And then it goes ahead and initializes the data structure. And now, from the point of view of the API, the most important call is this one right here. There's a function called amconfigure, and that one establishes the connection between your audio module and the Patchfield service. So this configure method takes the handle that you received earlier. So you receive the handle in the configure method, and you just hand it over to this function call right here. Then it takes a process function that you implement and that provides the audio processing capability that you want, and then you give it the data structure that we just created. Okay, let's take a look at our audio processing function. It's right here. So this one initially just retrieves the data structure that we allocated earlier, and then it extracts the filter update coefficient from this data structure. And there's one crucial point in here, namely it retrieves this update coefficient using a GCC built-in called sync, fetch, and or. And the point here is to access this coefficient in an atomic way, because we need to worry about thread safety here. This coefficient may be changed by a different thread. When you move the slider in the UI, then the UI thread will change this coefficient. But we're in the audio thread here, and so we need to make sure we're properly synchronized, and this GCC built-in takes care of that. Okay, so now once we've retrieved our filter update coefficient in a thread-safe fashion, we can do the actual signal processing, and that's happening right here. So we iterate over our buffers, we read our input samples, we perform our signal processing magic, and we write our output buffers. So in particular, if you've studied signal processing, then you will recognize this line right here. This is just the update formula of a simple RC low-pass filter. And that's it as far as the code is concerned. All right, so that's it for now. You can find the source code at GitHub, and there's a forum at Google Groups, and don't hesitate to get in touch if you have any questions or comments. Happy hacking!